Hello boys and girls, this is a video about solving systems of equations. And solving systems of equations basically means you have two linear equations and those lines are not parallel to each other and those lines are not the same lines as each other, which means that they cross in one location. They could cross in any way, but they cross one time. So there are two main methods that we will use to solve our systems of equations, and the first one that I'm going to show you how to do is the substitution method. The main idea behind the substitution method is that at the point where these two lines intersect, or where these two equations intersect, the x value is equal in both cases and the y value is equal in both cases. So if we know that y is equal to negative x minus 4, but we also know that that same exact number is equal to 2x plus 8, since it's going to be the same number for y in both of these situations, what we're allowed to do is set these as equal to each other and get rid of the y. So I'm just going to rewrite this part. Negative x minus 4 is equal to, and I'm just going to rewrite this part from this equation, 2x plus 8. So now that we just have x's and constants, we can just use our algebraic manipulation in order to solve for x. So I'm going to move this x to this side. I'm going to add x to both sides. It's a negative x here, positive x here. Now I want this 8. Well, you know what? Let's rewrite our equation. We have negative 4 equals 3x plus 8. Now I want this 8 to come to the other side. We will subtract 8 from both sides. We have negative 4 minus 8 is negative 12 equals 3x. We will divide by 3. We will divide both sides by 3. Negative 4 equals x. Alright, so now that we have solved for x, we will take that number and we will throw it back into one of our equations and solve for y that way. So we know x is negative 4. So I'm going to look at our bottom equation. I feel like that will be easier. So we have y equals negative 4 minus 4. Interesting. Okay, so negative 4 is a positive 4. So y equals positive 4 minus 4. What is 4 minus 4? Y equals 0. So now that we think we know that the x is negative 4 and the y is 0, let's go to the top equation and see if that's correct. So I will plug in the y value of 0, the x value of negative 4, and let's see if our numbers are correct. If they are correct, we will have the same number on the left and right hand sides of our equation. So we have 0 equals 2 times negative 4 plus 8. So let's see here, 2 times negative 4 is negative 8. 0 equals negative 8 plus 8. Negative 8 plus 8 is 0. 0 equals 0. And we can put a big check next to it. We have found the correct answer. So the correct solution using substitution is -4, 0. If you think of it this way, if there's graphs, this is the point where they both intersect. If you're just thinking of the lines on paper and using the numbers, these are the numbers that will fit into x and y into both of these equations. It's the only point that will work. Okay, so let's clear up some space. Because I don't want to erase this fish. Elimination. Elimination is the second method that we are going to look at today. And the main principle of elimination is that we want to combine our equations, which we're allowed to do because we know that 5 is equal to this much, 5 is also equal to this much. So when we combine this side, we know that it's 5 plus 5, and we know this side is 5 plus 5. So we're not breaking any rules as long as we follow all of the other rules. So what we want to do is we want to create a situation where when we combine them, we are eliminating one of our variables. We can get rid of our x or we can get rid of our y. So I think the best thing that we could do is multiply this whole equation by 3. And the reason I'm picking 3 is because I have a negative 3x in my top equation. So if I multiply the bottom by 3, I will have a positive 3x on bottom, and they will eliminate. So let's do that. Let's multiply everything on bottom by 3. So this will become, oh, that's bad. Let me get a different marker. Okay. We can just go back to the black. We'll have 3x minus 6y equals 15. Okay, so all we did was multiply every part of this by 3. The negatives stay the same, the positives stay the same. We haven't changed that. So I can stop looking at this one. In fact, I'll rewrite it up here. And then I'm going to erase it, so that it's not in the way as I decide to add my equations together. So we are going to add the negative 3x and the positive 3x. They eliminate, they're 0. We have a negative 4y and a negative 6y. They combine to be negative 10y. We have a 5, positive 5, and a positive 15. We add them together, they combine to be 20. I have negative 10y equals 20. Let's divide both sides by negative 10. And we find that y equals to negative 2. Y equals negative 2. And now we go back, do the substitution method one more time. We plug in y, we plug in negative 2 for y, and solve for x. So now it becomes substitution again. Let's use the equation that we kind of set to the side, because that'll be the easiest thing here. We have x minus 2 times negative 2 equals 5. Well, negative 2 times negative 2, it's going to be a positive 4. X plus 4 equals 5. Some of you probably know the answer by now. We will subtract 4, we will subtract 4. X equals 1. Now let's double check this. We know it works here, But let's double check these numbers to make sure that we have the right answers. So we will go to the other equation, the one that we did not use, and we will plug in 1 for x, -2 for y, and let's see if it works for this one. So we have basically -3 times 1 minus 4 times -2 equals 5. Okay. So -3 times 1 is just still -3. -4 times -2 is +8. So -3 plus 8 equals 5. Well, -3 plus 8 equals 5. And 5 equals 5. Big check, we have the correct answer. So in elimination, typically we have linear equations in standard form, as in x and y are both on the left side. The right side has just a number, a constant number. Whereas with substitution, it's good with a slope-intercept form of the line. So these are the two main ways that we solve linear equations, and that is the end of the video. Thank you.